back to Open Med School. Last time we have discussed about the interpretation of ABG starting with the oxygenation and ventilation, that is FiO₂. We have discussed about the calculation of alveolar arterial gradient. Today I will be discussing a case to explain the alveolar arterial gradient and adjustment with age and FiO₂. So let us see the ABG report. This is a 55-year-old patient. FiO₂ is 40%, that is 0.4 is the FiO₂. The pH is 7.38, PaCO2 is 42, PaO₂. So first thing I have to look for is what is the PaO₂. PaO₂ is 90, there is no hypoxemia. The FiO₂, any patient with whenever there is a PaO₂, we check the fractional of inspired oxygen, it is 40%. So here is the patient is having a normal PaO₂. Normally is considered as more than 80 to 100 is the normal. So normal with in FiO₂ of 40%. So step 1 in analysis, you have to calculate the alveolar oxygen tension, that is PaO₂. PaO₂ is calculated using the alveolar gas equation that we have already set. FiO₂ into barometric pressure atmospheric minus vapor pressure water minus PaCO₂ divided by the respiratory quotient, that is 0.8. So here the FiO₂ is 40%, that is 0.4. Atmospheric pressure is 760, water pressure is 47, PaCO₂ is 42. So from this we can calculate the PaO₂. And the PaO₂ calculation simplified will be PaO₂ is equal to 150 minus PaCO₂ by 0.8. This is approximately 285. Minus 52.5 is equal to 232. You may use a calculator to calculate this. So the first step, when there is, you see the ABG, identify PaO₂, that is arterial oxygen tension, see whether the patient has hypoxemia, then look at the FiO₂, then calculate the alveolar oxygen tension or PaO₂. Next we go into calculation of the AA gradient. As we know, AA gradient is the difference in the pressure between the alveolar oxygen tension and arterial oxygen tension. So here it is 90 was the PaO₂, and the alveolar pressure we have already calculated is 232. So it came as 147. So this patient has got a normal value for the AA gradient is, for the normal adult, it should be less than 15 to less than, or it is 5 to 15. But there are several different, the age and other things will be interfering with it. So you can say that definitely it is high in this patient. So here you should understand that you have to adjust the AA gradient with age. So there is different formulas are there. Simple formula is age plus 10 divided by 4. Another formulas sometimes used is age divided by 4 plus 4. Both will give approximately. So easy to use is this formula, age plus 10 divided by 4. So in this patient, the patient's age is 55. So 55 plus 10 divided by 4. It is around 16 millimeters of mercury. So the AA gradient for this patient, if he was inspiring normal air, that is 21% inspired oxygen FiO₂. But here you should know that this patient is having FiO₂ 0.4. So we had to do adjustment for that. So expected AA gradient for different FiO₂ values are there. So 40% oxygen is 20 to 30 millimeters. For 50% it is around 30 to 40. So even though this patient, our calculated value is for a normal person in normal atmospheric air. So here it will be, you should to take it as 30 to 40. Or at least 22, sorry, not 30 to 40, it is 20 to 30 millimeters of mercury as a patient is on 40% oxygen. Hope this point is clear to you. So now we are going to the clinical interpretation of this case. The normal AA gradient in this patient 40% oxygen should be less than 30. So this what can happen? This can occur hypoventilation. Patient is an opioid overuse, neuromuscular disease you can get. AA gradient more than 30 millimeters mercury. So you have to suspect BQ mismatch. Can occur in COPD, pneumonia, pulmonary embolism. These are the common conditions where you get. Or there may be diffusion defect, interstitial lung disease, or right to left shunt. So the basic problems you should remember is that when the alveolar material AA gradient is normal for the age and the inspired oxygen, the conditions are related to hypoventilation, and if it is high, you have to consider some abnormalities in the ventilation perfusion mismatch or disorders of the lung. In this case, if it is an acute onset, the most likely condition you have to consider is pulmonary embolism. Or the patient is having fever, etc. This may be due to pneumonia. So by interpreting the clinical setting, we can come to a conclusion what is the reason for this. So the final summary of the case is the PaO₂, alveolar oxygen 232, AA gradient is 142.7, expected is less than 30. So there is significant oxygenation impairment likely to be due to BQ mismatch or due to shunting. Only by looking in the clinical setting, we can come to a final conclusion. Hope this example is clear to you. Thank you.